G'day, Dave Galt here. I'll share my screen. Share. Wait. And minimize that. Okay. And okay. I was sent a set of occultation observations summarized in an occult XML file, and I'm helping Ernie to process it. So this is the event here. It has this is the prediction crossing the USA. Magnitude 12.7 target star, 13.8 asteroid, mag drop of 1.4, which is equivalent to 74% in visual, and 1.2, 67% in red. So it should be a fairly easy drop. However, to observe. However, Jean Moroz, I think that's how you pronounce your name. If it's wrong, I apologise, Jean. He observed a potential drop approximately 15 to 16 seconds early. So the first, is this noise or is this a real drop? And if it's a real drop, how could that be? 17 seconds early. So playing around earlier this morning, I set up a potential double star, which is the only thing which would explain the situation. So now, this is a normal double star display. Zoom out a bit more, where you have all the chords and a bright star and a secondary star at a certain position angle. Occult has a function where you that's with all the chords aligned. You can unalign the chords like so, and that shows you the potential asteroid with respect to the two stars. So if it's real, there's three chords over here, two chords almost on top of each other, and Jean's potential chord is over here. Now, Jean says that possible positive mag drop report, he's observed a 9.2% mag drop. So if that's true, well, let's have a look. At the same time, Ted Blank has observed a mag drop of 71%, and Joan and David, I think Dunham, observed a drop of 75%, which was in line with what was predicted, as was Ted's. But unfortunately, Paul doesn't have a mag drop specified. So what I've decided to do is, after fixing my itchy ear, is to all the mag drops specified by Ted and Joan come from Pyote, but let's have a look at them in the occult Vizier light curve generator, because that gives you playing around with the sky plane plot and the light curves at the same time. So anyway, how would you do that? Ernie has sent me the 4 CSV files, so let's have a quick look at them. Ted blank, open. Target tracking and no star, and get rid of that. Yes, okay, fine. So yuck. So we can turn off the blank and the comp star. Now, when you got this open, you can right click and display an approximate light level for the full light region. So is that about right? I guess so, maybe a bit higher. And when you mouse over here, it will give you a height of 30% based on that red line. So straight away, you don't have to go through all the pyote loading and processing. You can simply set a full light level and mouse over to get about 30, somewhere around 30%. And Ted, he is actually reported from pyote that the mag drop was 71%. So straight away we can see that we were in agreement with pyote without all the drama. So we agree with Ted's pyote analysis, and you can also, with the left edge of the arrow, see that the event time 57.6 tallies pretty good with the computed time from pyote. So we're very happy with pyote. So that's all in my opinion, that's all the review you need to do of Ted's observations. The reappearance is 4, 8, and 0.53 seconds, which in the pyote analysis is 0.6. So we're not disputing anything. So we've reviewed that in about 10 seconds if I wasn't chatting. So same with Jones. We right click and we load the Dunham. Now Jones done a series of nests, so pick one of them. I'll pick that one. And you can turn off the comparison stars, and we'll zoom in a bit, maybe a bit more. 5. Is that too much? Where's the events here? Again, by eye, you just right click to place the red levels. That's maybe a bit high, somewhere around there. And now you can mouse over here and see a drop of 26%. Sorry, a height of 26%. The inverse of that is 75%. So, and pyote has given a mag drop of 75%. So you can very quickly assess Jones processing without too much drama. Again, the time is 57 point. Yes, we're on the in the ballpark. Well done, Joan. And so the times and the drops compute. Now, Paul's, get rid of that. Paul's has used a HX camera, I think, 910 HX. Okay, and at 8 times times frame integration. This works in frames, not fields. And there it is. Again, right click somewhere here to set an average height, and you can see Paul's drop is about well, the inverse of 24%, so that's what's that, 76%. So we're all around the right number of the expected drop. Now, if we go into Gene's light curve, Gene Moroz, he's used a BD, 910 BD camera at because he's got a bigger scope than Paul Malley. He's only used 2 frames. So left click on the first step. Sometimes it's easier just to use these ones up here. Left click and right click gets the 2 frame integration. Now, it's a big long light curve. Turn off the comp star. Move it over here. Now, Gene has said the disappearance is around 758, 758, and the reappearance computes as 1.6. Now, that's somewhere around here. That might be that in there. Is that real? Let's zoom in a bit. 1 is good enough. So we're looking for the event that Gene has claimed, and that would appear to be it here. So he's claiming a disappearance of 58 and a reappearance of 1.6, which is somewhere around there. Now, I think if you look at that and what's here, I don't think you're on the money, Gene, but we'll set the levels. And is that a bit low? You can certainly see the drop in the light curve that may or may not be real, but for it to be real, would mean that the other 3 light curves of Ted, Joan, and Paul would need to be suppressed by the amount that Gene is claiming, and we've already shown that 3 observers have observed a drop of around 74%. So it's not looking good, Gene. I'm afraid that I don't think what you've claimed as real is in fact real. So bad luck. I wouldn't. However, let's get rid of that. I'll open up. So unlikely is my determination. So we might go back to the original OBS file that Ernie sent earlier. So we'll open that. Yeah. Get rid of the Alt-M to get rid of the modeling, and we'll zoom in a bit more, and we'll get rid of that. So there's the 3 chords, and there's the event that we've determined is unlikely. Based on unclear light curve and the fact that these 3 light curves should be suppressed So we should have a drop of, instead of 74%, around about 60 to 65% maybe, which we don't see. So we're not allowing that. But I believe Gene's done the right thing. Where as observers, our job is to report on what we see. So I'd like to suggest we preserve that information. But we've reviewed it, and we don't agree. So I'm going to suggest we do this. Possible, positive. And we'll put a space in there just for mag drop. We're going to put in, I'm the editor, Ed. Reviewed, liked, curve, and not I don't know what to say. Not proven. Other 3 chords drop as expected. There we go. Other 3, CHORD. Learn to spell or type. Right. So I'm going to add that to the record. Now, when you look at the plot, we're not allowing that, but that is that a true miss? So we're not going to throw away your observation, Gene. We're going to do this. We're going to simply add a new record. We don't need all this guff now. Add, and we're going to turn it in. Is it a miss? We're going to guess it's going to be a miss, and we replace. So now we've got 2 lines for Gene. One is a claimed positive, which we're going to give it as a weight of 0, which means occult will ignore it. And to make it look nice or like clear on the plot, we're going to exclude it. So now we have the 3 positive chords and another chord here. What time at Gene's site would have Gene seen an event? So all we need to do is click here, set miss times. And we're going to adjust Gene's times by 17 seconds. So there it is there. So we click on the miss chord for Gene. We don't need, we shouldn't have plus or minus errors in a miss chord. That's crazy. But Gene should have seen an event around 4, 8, 15.8. So let's have a look at that light curve again. Gene Moroz, Lucina. 2-frame binning. Oops. Right. So that was left click and right click properly this time. There we go. Okay. So and we don't need the comp star. Whoops. So where on this chord is 4815.8? So there it is. That's the thing that we think or originally thought. So 4815.8. We'll go in a bit more. For mouse over again. 48. Oh, mate, way up here somewhere. 4815. There we go. 4815.8. So if Gene's miss here was in fact a positive, he should have a 74% drop at this instant here. There it is there. 18 point, whoop, get it out of the way. 4815.8. There should be a large drop here, and there isn't. So Gene's observation is definitely a miss, without doubt. Now, we all know about adding Vizier light curves for positive events. And in this particular case, there's a valid argument to add a light curve for a miss. There's no reason why we can't do that. So, say you're all the three other light curves have durations set up for 40 seconds. Let's set up one for Gene at the right time for 40 seconds. So where's 15.8? So start. There you go. Start there. Half of 40 seconds duration is 20 seconds. So it's 15.8, 25, 30 point. Oh, it's too big. Let's drop it down a bit. What we want to do is create a Vizier light curve demonstrating that Gene observed a miss. 25, somewhere around there. And move it back. So now we can create a light curve centered on 15.8, which clearly shows a miss. Save report. Hope that's clear. So Gene definitely observed a miss. Yeah. Now we need to fit an ellipse. The easiest thing to do, which is to make sure all the check boxes are on, and let's see what we get. That's interesting. Not surprising. So let's the object has a assumed diameter of 137. So let's make this. We'll turn off the major axis and make it fixed, and we'll type in 150. Just a number out on the top of my head. And we use the algorithm to do its thing. It's a bit long, I think. 140. Oh, let's say 145. Too big still. 140. Let's have a look at those models again. So, move this down here out of the way. make the chords bigger. Can we find something that's a bit rounder that will fit these points here and a miss? So let's make this 135. Click, 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 click. Too big still. 130. That's, yeah, 128. There you go. Now, is this, well, this is a result of the observations. We got 3 high quality chords. There's 2 underneath there and 1 there. We can't argue with those, and we can't argue with the miss. We've already established that. Is that real? Now, the assumed diameter of 137 comes from the list, the IR diameters here, and honestly, the findings from the IR satellites, 153, 131, 132, I think, judging by that and these numbers here, I think Neowise is a bit high, and the other two are closer together. So let's keep 130 in the back of our mind. Also, if we have a look at list light curve data, that pops up over there on my computer. I'll drag this back to here. The light curve data is implying an object with an axis ratio of 1.15 to 1. So it's definitely an ellipse of some description. But it looks a bit on the small side compared to the observed chords. Now, historically, we'll go to all the shape models, and the number is 146. The identifier 146. 146. Lucina. There's been 21 observations of occultations observations involving Lucina. There's only one where somebody's managed to fit a poor fit, and notice it's 124 to 127. Lots of diameters but no fit, and they're all pretty small. Here we're going to go minimum diameter. That's single chord events. They're all pretty small. There's 142, and not contained. There's no good fits, and there's only one poor fit. So it's what we're going to achieve is not unrealistic compared to history. The 1.15, where's my electronic brain? We've got an ellipse of 104. 128 divided by 1.15. That gives 111 as the minor axis based on that. So we've got an ellipse that's a bit elongated compared to the hang on. Can I pause this for a moment? Where's my open recordings? Pause. Okay, so sorry about that. I had to answer the door. So according to the, where were we? According to the asteroid light curve, come on out of the way. Light curve data, the ALCD, keeps on popping up over on my second screen. We have a maximum axis ratio of 1.15 to 1, and we've determined that the ellipse that I've drawn here is too long. So let's drop that down to 1, 1, 5. How does that fit? So, okay, that's kind of 115 divided by 1.15, 100. So, I'm going to leave it at that. That's so the assumed diameter based on, let's leave that up. The IR diameters. It would appear that let's not jump too far ahead. So I've now got a best fit ellipse that meets the maximum axis ratio, but it's undersized compared to all the IR diameters. Oh, well. How does it fit to the model? 3D model. So we'll click on the first one. And so we'll drag this across here a little bit. Down, always go the wrong way. This model kind of meets the observed points and the miss. So I'm going to set now you've only got a small contact area on the limb of the shape model, so you can't. I don't think you can choose a good fit or a poor fit with only 20% of the asteroid with chords. So at best, with this sort of thing, minimum diameter is not applicable. So it's either a diameter but no fit, or you give up completely and you go not constrained. But we can, the MIST chord boxes it in nicely. So let's go diameter but no fit, and we'll adjust. We'll set a maximum, and we'll come down a smidge and fit a minimum. That's what I've decided to do, right or wrong. Now, this one here is a bit fatter. And so we'll do the same thing. Diameter no fit, and we make it a smidge smaller. Coincidentally, both shape models have the same max and min. What does that tell you? Now, I'm not happy about this ellipse, so I'm going to disobey the light curve diameter, and I'm going to make it a better fit to the two shape models. So I'm just going to put that back up to 120 and hit the best fit ellipse a few times. So is that I wonder, go the other way. We'll turn that. We'll define the minimum diameter. So let's make that 110, and let the major axis be computed. Oh no, you can't do that. That's not too bad. So 126, let's call it 127, divided by 1.15, 110. Wow, that's the solution that I'm going to now. The final thing to do. So we've set the two shape models. Now we're going to I'm going to go out on a limb here, and no, we can't do that. We've got no shape. Limits on size, but no shape. Well, we do have a shape, but we haven't given it a fit. I'm going to choose the higher quality one and let see if Mr. Herald wants to dispute with me. I'm going to save it at that. Now, the final thing to do, because we've restricted the we've input this minor axis, we need to tell everybody that that was deliberate. So we close. We'll choose the right line first, and we're going to write in. I'm the editor. Minor axis assumed, and I'm going to replace that. Yep, and I think I'm happy about that. It's the IR diameter is on the small side, 120, but that's in agreement with or closer in agreement with the AQA and IRAS than, but NeoWise is way off the mark. Don't know why. That's about it. Okay, I hope that's useful. I hope it's right. more to the point, and I hope it's useful. I'm going to come on, stop my share and stop the recording.